Okay, so we're into the second video now. The second thing we're doing to kind of mess around with our ecosystems. We talked previously about what we're doing with nutrients in the cycles. Now we're going to talk about pesticides. Let's take a look here. So pests. Also, you can call your younger siblings pests as well. In my case, it's my older siblings. They're both pests. Anyways, there are organisms that might compete or damage like a crop or something you're trying to grow. So weeds, think of your garden, right? You got lots of weeds in your garden, and they're competing for resources with your tomato plants. In fact, I'm looking at my garden right now. I need to go pull some weeds out, like mosquitoes, mice. I don't know, pretty much anything that's competing with us for things we want. And the term pest is used only in reference to human wishes. Okay, in nature, everything has a place. Everything has a reason for being there. It's just us that seem to not want to have them. So it's really just a human perspective. Okay, that's what pests are. And then pesticides are poisons we use to select for that pest and kill it off. All right, so we can use like herbicides for certain plants we want to kill off in weeds, insecticides for insects, rodenticides for rodents, fungicides for fungi, mushrooms and stuff. But these are all pesticides. They're just specifically named. Okay, so like herbicides, insecticides, rodenticides, fungicides. But if you called it a pesticide, it's still correct. Right. So there you go. And the characters is that there's two kinds, right? There's ones that live short and ones that live long. So some, if you just have some ants around your house, you might want to use one that's short lasting because it'll just kill off the little colony and you move on your way. But let's say you got lots of weeds in your garden and you're going to be gardening for the summer, you might want to use a pesticide that stays around for a long time, like this guy here, Roundup. But you can't really get this one on the market anymore. There are natural sources, so there's natural kind of pesticides or whatnot that we can use. And then there's ones that we've, chemically engineered to be kind of like the nuclear weapon option on pests. So, yep. Anything you want to add to that one?
Nope.
Okay, so another consideration is extent of control. So if you want to use something that'll kill off a wide kind of range of species or something that'll specifically target the species you're looking for. So for example, DDT, I'm not even going to say that name. Well, maybe I will. Dichlorophenol
Diphenyl. Dichloro-diphenyl trichloroethane.
I missed the di in there. Okay, I missed the di in there. So dichloro-diphenyl trichloroethane. Okay, nice. Now DDT was used to kill off almost all insect species. Really what they're targeting is mosquitoes usually, but they use it because they're just so effective at killing off all kind of pesky insects. BT is a modern pesticide that only works against like caterpillars, bee larvae, anything that's kind of in a larval state. So, I mean, this one would kind of kill off everything, and this one would be more targeted. So, there you go. Non-targeted species, problem is they end up killing off a lot of things that we don't want to kill off. So the case is the island of Borneo, right? So what happened in Borneo was it was bombed to shreds. It's an island down in Indonesia, and it was bombed to shreds during World War II. The Japanese were holding it, and the Allies bombed them out. And so you end up with all these giant craters. And in these craters, you have water, standing water that's not flowing, and that's the perfect spot for mosquitoes. So you end up growing a lot of mosquitoes, and the mosquitoes were giving malaria to everyone. So we said, hey, well, we'll just blast the island with DDT because it'll kill off the mosquitoes. But what it also did was kill off the cockroaches, right? And well, actually, I don't think it killed the cockroaches. It just made the cockroaches full of DDT, which then when the geckos ate the cockroaches, it made the geckos sick. And then the geckos were now lazy and wouldn't eat the caterpillars.
Yeah, it slowed down the cockroaches so the geckos could catch it faster.
Oh, right. So then they stopped eating the caterpillars. And then the caterpillars would end up eating the roofs off of people. And then what would happen is the cats would eat the geckos because now the geckos were slowing down because they have poison. But then there was so much poison that it ended up killing off the cats, which then the cats weren't able to eat the rats anymore. And then the rats carried fleas, and then the fleas ended up giving typhoid fever to people, which then ended up killing off more people. So
Yep.
long story short, we used DDT to kill off mosquitoes to get rid of malaria, but we ended up creating through this chain of events a disease much more deadly to people. So it ended up hurting us, some year or two later, a little while later, right? So I know. I mean, the solution was pretty funny. They ended up rounding up a bunch of cats and dropping them in the forest to kill off more rats. So, anyways. So that's kind of one of those things where it's like you use a broad-based one, it's not always good, right? The DDT actually ended up causing more problems for us than it solved. But some places, like in Africa, they use DDT to kill off mosquitoes for malaria, and it actually helps communities. Any sort of side effect is definitely not as bad as the malaria that they're getting. So there we go. Now the issue with pesticides is it does something called accumulates, right? So when you eat that little piece of pesticide or that little chemical, it sticks around in you. So you can't get rid of it. So, I mean, maybe you get rid of a little bit of it, but it builds up in you. So the more you eat, the more it builds up in you. Okay. Now, at low levels, a lot of things are not bad, but they do build up over time. And as they build up over time, it does something called biomagnification, which means as it goes up the food web, as it goes up the trophic levels, it actually multiplies and exponentially grows. And so we have bioaccumulation, which is the organism getting the poison in them through things that they're eating, and then also the idea that every level up the food web you go, it magnifies as well. And I think we have a little picture here to show you. Okay, yeah, so we can look here. So let's say the algae's eating this little kind of chunk of poison. I don't know. What do we want to call it? I don't know. Maybe it needs methyl mercury, whatever.
Sure.
We'll go with mercury. It's a common one, right? So the algae might take in a little bit, and the dots are kind of representing the density of kind of poisons in it. And so this algae, there's quite a lot of algae, and there's not, each little algae doesn't have very much. But then the shrimp eat, let's say, 5 or 6 algae each, right? Well, that shrimp is now taking all the poisons from each one of those algae. So now the shrimp will have 5 times the amount of mercury that the algae did, because it's taking the algae, or it's taking the methyl mercury from each one of the algae that it eats. And then you have the cod, which eat a whole bunch of shrimp. So now they're taking all the poisons from each shrimp, and it multiplies, right? And then the ring seal is eating a bunch of cod, which then multiplies even further. And then by the time you get to the polar bear, you've gone from like levels of like 1 part per trillion here to like multiple parts per thousand here, and that's enough that ends up killing off the polar bear. So the higher up the food, the higher up the trophic level you go, the more toxic it becomes. I think, yeah. So then that's kind of what goes on there. And I mean, we used to show presentations that had numbers and stuff. There's a video that we're going to attach where we encourage you to watch, because it has like a little simulation showing fish eating each other. And go ahead and watch that video. It'll be attached in the folder. But you just got to know that biomagnification is every level you go up, it kind of multiplies the amount you have, where accumulation is that organism, how much that organism is getting. Right? So they're all bioaccumulating, and it magnifies up the trophic levels as we go. Anything you want to add to that one?
I think I've been adding it as I go. So
Perfect.
I think I'm good.
Excellent. Okay. And it's really the top predators that end up kind of running into problems here. I mean, these guys down here, it's such a low level that although they have the mercury in them, it doesn't really hurt them. Once you get it to the top, then it starts really causing problems. Okay, another problem is you get what's called pesticide resistance. So I'm spraying this stuff to try to, and I'm actually using my hands to spray right now. I know you can't see it, but to spray to get rid of it. Now, let's say you had, a whole bunch of, I don't know, what are we going to call these, cockroaches? Don't know. Fleas.
Looks like it. Whatever.
Yeah. So let's say you got a bunch of roaches, right? Well, there's going to be a few of them, maybe like 1% of the population that would be resistant to that poison, right? Well, now they're the only ones that are left. So the next generation, when they grow, all of the ones you have are now resistant to that poison. So you'd have to spray something else to it. Okay. And so they end up becoming immune to it over time. It's the same idea when you take like antibiotics, why you need to really finish it, because if you don't finish it, it's strong enough that it kind of kills everything, but you can actually end up creating antibiotic resistant bacteria in you if you don't finish that prescription. And then you're in real big trouble, because then we don't have stuff to treat it. Okay, so I mean, there is some problems where if you keep spraying. So typically, if you own a farm or something and you're spraying pesticides, you're going to spray different kinds of pesticides on a schedule. So one time I use this one time I use that one, so that you're not going to develop kind of this what's it called, group of like resistant ones that hang out. but then you're spraying all kinds of chemicals, and now those chemicals are going on your food, right? So this is especially why it's important for you to wash your fruits and vegetables before you eat them, because they might have some of the stuff on the outside of them. All right. So vocabulary, you want to know about pests, pesticides, target, non-target, bioaccumulation, bioamplification, and amplification, magnification, same sort of word there, and then pesticide resistance. Okay, so that's it for that one. If you have questions about bioaccumulation, biomagnification, and issues with pesticides, feel free to let us know.